Now that we saw in the previous video that we utilize iter tools combination that is offered by Python internally to create all kinds of possible combination that can exist within a list. Now let's say if an interviewer or in some interview you are supposed to write your own scratch logic, how you are going to do this. So this video aims to highlight that those algorithms. So I have found two of the lenient algorithms that once or twice practice that can be easily memorized and that can be easily implemented in your interviews, right? One of the technique is bitwise operation. So again to iterate on this whole thing, on this whole problem statement, given a list 1 to 3, what we aim to create all kinds of unique combination that can exist. What this bitwise operation talks about in principle is we go from 0 to 2 raised to n minus 1. If you initialize from 0 to 2 raised to n minus 1, you will also get an empty list as part of the combination here. If you want to avoid it, you can start from 1 and you can go up to 2 raised to n minus 1. So you go as a binary mask. Each bit in the mask tells us whether to include the corresponding element from the list, right? By that, what do I mean? Consider this particular row. So if you have a mask 001, right? So here the most significant bit that is set is 1 here, right? And corresponding element to this is index 0. So when you iterate at the mask loop and when you iterate at the inner loop that we will write in our code, when both of these bits are set, then only your combination will be considered as part of the subset. When you iterate further, you will have so this combination again, to reiterate what I just spoke, in principle this bitwise operation talks about all of these bits will go up to 2 raised to n minus 1. So all kinds of possible combination will exist over here, right? So this is one possible combination, the other possible combination is 010. So over here this bit is set, right? And corresponding element to this is index 1. So whenever this bit is set and our inner loop is iterating through the index 1, so at index 1 which element is present? 2 is present. So accordingly 2 will be considered as part of the subset. Now consider this. When we get a mask combination of 0 1 1, now which bit is set? This is 0, this is 1, right? So this corresponds to the 0th index and first index of the given input list, right? So accordingly 1 and 2 will be considered as part of the combination. Now moving forward, when we have 100, so here the bit that is set is index 2, right? So accordingly at index 2 what element we have? We have 3. So that will get set and that will be considered as part of the subset. Now we move ahead and we write the code for mask in range of, as I said, you can write 1 or you can write 0. In principle you have to go 0 to 2 raised to n minus 1, but for the demo purpose I am avoiding the empty list combination, right? So this is the syntax of going up to 2 raised to n minus 1, where n is equal to length of input list and input list is equal to 1 comma 2 comma 3, right? Now we create an internal list called as combo. Now we iterate further and we write for I in range of n, right? So consider this mask to have value like 0 0 0 0 0 1 and all, and consider this I to have value like 0 1 corresponding to the indexes that we have, right? Now what we have to do, we need to do if mask and 1 less than I, right? So this in principle this is what I just explained to you. So when the index is like let's say 0 and if the mask value is 001, so here this bit is set and here this bit is set. So this is telling us that this corresponding element needs to be considered as part of the subset. So now what we do, we append this combo dot append input list of I, right? And we can create the resultant list now. Result list dot append combo. That's about it. So once you understand how this whole thing in principle is working, the code is fairly simple. When you print it and when you execute it, This is creating all kinds of combination. As I said, you can change this to 0, so this will go up from 0 to 2 raised to n minus 1, and it will also consider your empty list, right? Other than this bitwise operation, there is one more algorithm which I have found lenient enough. But however, my personal preference would be that you implement, just in case you get a surprise from any interviewer, that you are expected to write a code from scratch, building all kinds of possible combination. Because in principle, even the explanation part is fairly intuitive, right? So I'll suggest just practice this one or twice and you will be able to ace it. Anyhow, there is one more algorithm for to achieve the common goal that uses a recursion, and that internally uses backtracking. By backtracking, what do we mean? We walk through the list from left to right, and at every element, we make a simple decision: should I take this element or should I skip it? So there is this yes or no choice. So take for example again, given this list 1 2 3, if we take one, our current combination become one. Now we have a choice: we can move forward to two, or we can not move forward to two, right? So if we take the root of 1 2, this will create a possibility of choosing 1 to 3, right? And if we wouldn't have taken the root 2, the other possible combination would have been 1 2 3. So you realize, while we are discussing that different kind of combination are getting created while we are discussing it. So this is what this whole backtracking is works upon, right? So considering this, we took the root of 2, then we chose 1 2 3, right? And then we backtrack. So basically, by backtracking, what we mean is we undo the last choice and try other options. So after finishing 1 2 and 1 2 3, we come back, skip the 2, and now it opens up the possibility of 1 3. Once we finish all possibilities that start with 1, we backtrack again, skip 1 this time, then we repeat the same process, and this basically creates all kind of possible combination, and which is the basic reason why you see there is this difference between this sequence and this sequence. However, the sequence is not important for this particular problem statement. The main problem statement we want to address is creating all kinds of possible combination. So let's just code this thing in principle. So we create a function called as backtrack. We start with 0 and we pass the empty list. uh, this will be accepting something called as start, and this will be accepting something called as path, right? We will need the length of the input list, 1 comma 2 comma 3. Whenever we are recursively calling it, and if we get non-empty path, then we should append it to our resultant list by creating a copy of it. So when you do path, it will create a copy of this path, right? Now for I in range of start comma n, we go up to n, we do path dot append a of I. So this is the first decision choice that we make, right? We need to backtrack it before after all the recursion that we have done. Instead of a, it should have been input list of I. And this is what the decision tree or the all exploring all kind of possible combination snippet would look like. Here we pass I plus 1, and here we pass the complete path, right? uh, so yeah, that's about it. If we now go ahead and print the result list, this should print me the combination as suggested over here.